Today's notes are multiplication properties of exponents. And so we're going to actually cover 3 different properties today and apply the properties to different situations. By the end of the lesson, you should be able to say, I can simplify expressions involving multiplication properties of exponents. If you would like to start with a warm-up, go ahead and complete the following problems. And I will put the answers up in just 1 second. So if you completed the warm-up, the first problem, you should get an answer of 6. And for the second problem, you should get an answer of 4 over x to the 7th. Now, let's get started on multiplication properties. Our first property today is called the product of a power property. And so if we think about what that means, product is multiplication, and we have a power. So really what we do is we multiply powers with the same base. And so a definition is when multiplying 2 powers with the same base, we are going to add the exponents. And so if we are going to add the exponents, the generic example, a of m times a to the n would equal our base a, and then we would add our exponents to the m plus n. This right here is the product of a power property where we add our exponents. So looking at our 2 examples on the bottom, c to the 4th times c to the 7th. If we have 2 things with the same base, you add the exponents. So we have c to the 11th. 2 things with the same base are being multiplied. We're going to add the exponents. We keep the base, 2, and our exponent becomes 5. However, because this is 2 to the 5th, we can simplify even more. 2 to the 5th is 32. And that is our answer. So, go ahead and complete the next 3 examples. Remember, it is product of a power property. If we multiply 2 things with the same base, and they're being multiplied, we add our exponents. So, pause the video, complete them, and check back for answers. For number 1, you should have had a to the 13th. 2 should be x to the 5th, because remember on the single x, we have really a power of 1. And 3 should be y to the 9th. Our next property is the power of a power. So power of a power. We're going to raise a power to a power. That's exactly what it is. Take a power to another power. Now, when raising a power to a power, notice what we do. This time we are going to multiply our exponents. Not add like the product of a power property. We are going to multiply our exponents. So, in generic terms, a to the m raised to the n power. We're going to multiply these exponents, so we have a to the m times n. Raising a power to another power, we multiply our exponents. So, looking down at our 2 examples, 4 squared to the 5th. We are going to multiply our exponents. So we have 4 to the 10th. And then because it's a number, we should figure out what this is. And when we calculate 4 to the 10th, we get 1048576. So in this case, because it's such a big number, either answer would be fine. This down here is technically more simplified. In our last example, g to the 4 cubed. Remember, we multiply the exponents when we have a power of a power property. So we have g to the 12th. Go ahead, do these next 3 examples on your own. Pause the video. Once you finish them, come back to check your answers. Looking at the answers for number 4, our answer is x to the 8th. Number 5, you get the negative 3 raised to the 6th power. If you figure out what it is mathematically, you end up with 729. And number 6, we have the quantity k plus 2 raised to the 8th power. Our last property today is the power of a product. So notice the phrasing, power of a product. We raise a product to a power. So we raise something that's multiplied to a power. And so when raising a product to a power, we are going to distribute the exponent. So far we've added, we've multiplied, and now we are going to distribute. So a times b to the m, we're going to distribute the power m to both of these. So we're going to have a to the m times b to the m. So following the power of a product property, notice that in this example, they're multiplied. So here's our product, and we have to distribute this power to everything. If you really think about what's happening, there is the power 1 on both the x and the y. And so we're technically multiplying these powers together. And then it's going to be x to the 1 times 4, which is 4, and y to the 4 also. Looking at the next example, remember this is really a 5 to the 1, m to the 1. When we distribute that cubed power, we're technically multiplying once again. So we're going to have 5 cubed m cubed. However, we always want to take our numbers and make them without an exponent. We want to figure out just what it is. And 5 cubed is 125. Now we have that times m cubed still. Here are 3 examples that I want you to try on your own. So pause the video, try to answer them, and come back and check your answers. So looking at the answers for number 7, we just distribute the cubed exponent so we get x cubed y cubed. For number 8, when we distribute the squared exponent, we have to keep that negative 2 in parentheses. So we have negative 2 squared times x squared times y squared. The quantity negative 2 squared is really negative 2 times negative 2, which is a positive 4. So we get an answer of 4x squared y squared. However, 8 is different than 9 in the aspect that the negative is a standalone. So the negative does not change. The squared goes only to the 4 and the b. 4 squared is 4 times 4. So we have our negative 16b squared for our answer. And last but not least, these last 2 examples use a combination of all our multiplication rules. How I like to start with this first one is I have something squared and then that thing is cubed. I like to start by using my power of a power property where I multiply my exponents. So I'm going to think of this as negative 3 xy to the 6th power. From here, I'm going to use the power of a product property where I distribute this exponent of 6 to everything. Now, because this stuff is in parentheses, this negative 3, when we distribute that 6, needs to be in parentheses still. So we have negative 3 in parentheses to the 6th power, x to the 6th power, and y to the 6th power. From here, we can figure out what negative 3 to the 6th is. And if you calculate that, you get 729 x to the 6th, y to the 6th. And that would be your final answer. Looking at our next example, we have x times y times x squared y cubed cubed. Now, when you see this cubed out here, it's only going to the thing in parentheses that it's touching. It does not go all the way to the x and the y standing alone. So I'm going to use my power of a product property and distribute that cubed power first. This first x and y does not change. Times x to the 6th, because we're multiplying, and y to the 9th. Now, we can look beyond these parentheses. These parentheses just imply multiplication, but everything in here is being multiplied. So I like to look at this without parentheses. I like to think of this problem as x times y times x to the 6th times y to the 9th. When we look at the problem like this, we're really just going to use the product of a power property, where things with the same base have their exponents added together. So I'm going to have x to the 6 plus 1, which is 7, times y to the 1 plus 9, which is 10. And so x to the 7th, y to the 10th is my final answer.